11.2 talks about ellipses. So, definition of an ellipse, you could read that. I could draw you a quick diagram of an ellipse. It looks something like this, where the F1 and F2 they're referring to are right there. And if you connect those and stretch as far as you can and circulate, the circle will look something like this. Well, to us, the most important part is that if you have x minus h quantity squared over a squared plus y minus k quantity squared over b squared equal 1, or x minus h quantity squared over b squared plus y minus k squared. So you'll notice I switched those because I don't want you to get the idea that a is always under x and b is always under y. The book does that, we don't do that. And of course, everything's centered at the origin in section 11.2 and 11.3. 11.4 is where they shift those, so the shifts are not going to come up. Everything's going to be centered from the origin. Now the foci, in this case, and those are the two labeled right there, will be the square root of the larger minus the smaller in any order. So there's no set way of figuring that out. So let me start with an example right away. Let me go to the graph first. Sketch the graph of the ellipse, label the vertices and the foci. Alright, well, this is how we're going to do this. We're going to look at x squared and say what's underneath x, a 9. So what do you square to get a 9? 3. We're going to move 3 in the x, 1, 2, 3 from the center, and 3 to the left, and label those. And what's underneath y? That's going to go on the y-axis. And since that's a 16, what do you square to get 16? A 4. We're going to go up 4 and down 4. And something like this. Of course, it doesn't have to be perfect. There it is. That's the graph of an ellipse. The vertices are fairly simple to see once you get the graph. The vertices would be the stretched side. So what is that point? 0, 4, and 0, negative 4. And the foci would be always on the stretched side. That's called the major and minor axis. So I would find those by saying, let's say f equal, you know what, I drew that too big. I should have made it smaller. I can fix that with ease. So there it is. There's the graph. The foci would be the square root of the larger minus the smaller. So that's radical 7. The foci are always on the stretched side. Radical 7 is a number between 2 and 3, anywhere in there. And the foci will be square root of 7 and negative square root of 7. They want the length of the major and minor axis, major axis, and minor axis. Again, major axis is the stretched side. Since we went up 4 and down 4, that is 8. And the minor axis is always the compressed side. And the length of that would be 3 to the right, 3 to the left, 6 units. And that's how it works. So, it seems like a lot, but it's a lot simpler than you think. Let's tackle the next problem. Next problem says x squared over 16. So we stretch, what is square to get 16? 4. 4 to the left, 4 to the right. And y squared underneath it is a 9. What is square to get a 9? A 3. You go up 3 and down 3. Again, I'm making sure that you don't associate any of these numbers with any of the variables. Whatever you see, you label, and that's that. And your ellipse could look just like this. There we go. So, what is the center? Well, the vertices. Center is 0, 0, but the vertices are 4, 0, negative 4, 0. You could say plus or minus. I choose this because of the section 11.4. The foci are going to be on the axis. we know the major axis is the stretch side, that's 8 units. And the minor is the, oops, it didn't register. The minor axis is really 6 units. And the foci again is the square root of the larger minus the smaller, 16 minus 9. So I'm just showing it doesn't matter which way it goes. And there it is. So they want us to label that on every graph, and we're going to do that on every graph. Since everything is centered at the origin, these are fairly simple. It becomes just a bit more challenging when we do those with a shift, and we'll get to that in section 11.4. To get that, we really need to master this part out and get it out of the way. So here we are. I look at this problem. Now, the key, I forgot to mention. The key, make sure that's a 1. So, that's for an ellipse, a circle, and a hyperbola. Since that's not a 1, you could make it a 1. So it's x squared over 81 plus y squared over 9 equal a 1. So I'm going to run in the x direction 9 units. So in the x direction, we're going to run 2, 4, 6, 8, 10, minus right there. 2, 4, 6, 8, 10, minus right there, and we mark those. 2, 4, 6, 2, 4, 6, we want 3 is right there, and 3 is right there. And I can make the graph. I could scale this any way I wish. So the stretch is along the x-axis. Well, this is what we know. We know that the center is at 0, 0. They're not asking for the center, but there it is. Vertices, we know the vertices are 9, 0 and negative 9, 0. We know the foci are on the x-axis. Let me find out what those are. So the foci would be the square root of 81 minus 9. That's the square root of 72. So square root of 72, square root of 9 is 8. Square root of 81 is 9. So it has to be a number between 8 and 9, between 64 and 81. 1, 2, 3, 2, 4, 6. 2, 4, 6, 8. There's the foci, and there's the foci. So that would be the square root of 72 and negative the square root of 72. Of course, you could reduce that and say that's 36 times 2 if you wish. And that would be 6 radical 2. Now, the major and the minor. Well, major and the minor, those are the length of those. Well, the major is the stretch side. That's you went from 9 to negative 9. That's 18 units. And the minor is the compressed side. And you went 3 above and 3 below. That's 6 units. And there they are. And when I get to the last problem of these types, well, again, I'm going to set that equal to 1. That's the key. So I have x squared over 2 plus y squared over 4 equal a 1. So I'm going to run in the y direction 4 units and in the x direction 2 units, radical 2 units. I'm going to stretch this out just a bit more. Here we go. Maybe a bit more. Perfect. So if I run radical 2 to the right, 1, 2, radical 2 is right there. If it's not an integer, I would label that. That would be y's, negative radical 2. And in the y direction, 1, 2, and 1, 2. I don't know why I stretched it. There's the ellipse. We have a center. They're not asking for that, but I'm going to label it anyways. We have vertices. So the stretch side 0, 2, 0, negative 2. We have foci and major and minor. The major is running up to and down to, that's 4 units. The minor, radical 2 to the right, radical 2 to the left, it's really twice radical 2. Now to find the foci, the square root of the larger minus the smaller, that is radical 2. So I'm going to move radical 2, 1 point sum, and here they are, radical 2 and negative radical 2. Just a coincidence that they match the other coordinates. That's not normally the case. Okay, now going backwards, if I told you I have an equation of an ellipse satisfying the given conditions, now they're not asking for a graph, but if you put this on a grid, you'll get a very good idea of how this works. The vertices are at 4, 0, negative 4, 0. So that is x squared over plus y squared over equal a 1. And I noticed the stretches along the x, 4 units to the left, 4 units to the right, 4 squared is 16. And the foci are 2, 0 and negative 2, 0. So I know the foci is the square root. If I call this a squared, I'm going to always call it a squared. Isn't the larger 16 because the stretches along the x, and that's 2 units. Square both sides, and you have to do something like that in both sections, 11, 2 and 11, 3. Swap those. A squared is 12. Replace that by 12. There's my equation. It's very easy, given information, to come up with the equation. How about this problem? The same deal. They're not asking for a graph, but let's say the vertices are at 0, 5, 2, 4, 6. Again, since the graph is only for my reference, so I know it's x squared plus y squared equals 1. So we went up 5 units and down 5 units. I still want to figure out what a is. I notice the vertices at 0, radical 7. Radical 7 is a number between 2 and 3. So the square root of the larger minus the smaller, since the stretches along the y, this is bigger than what's underneath x, and that's radical 7. Square both sides, right? And swap those. A squared, 25 minus 7 is 18, and there's my equation for that for the ellipse. Again, very easy to go in this direction. Let me do 2 more. What if, and again, the graph is not part of this, that's why I'm not worried much about labeling. I'm just using it for my own reference. It says, in this problem, the foci are at 4, 0. Okay. And the length of the major, isn't the foci always on the stretch side? If the length of the major is 10, doesn't that mean they must have moved 5 to the right and 5 to the left? That means it's x squared over 25, because that's along the x, plus y squared over a squared equal a 1. And now I need to use this foci business. Foci is the square root of the larger minus the smaller, since the stretchings along the x, 25 is bigger than a squared. That is 4 units. Square both sides. Swap those. (25 minus 16 is a 9). And that would be the equation for this problem. There. Again, very easy to do. It's a lot easier to go from the information to the equation than the other way around. And what if they went and said, oh, the length of the major axis and the minor axis are 6 and 4. Well, that doesn't tell us much. They say the foci are on the y-axis. That means the major axis is 6 units. That means the y squared is over, you must have went up 3 and down 3. 3 squared is a 9. And the Minor is 4 units. I'm sorry, 4 units. Again, this is only for your reference. That's 4 units right there. 2 to the right, 2 to the left. That makes us 2 squared, which is 4. And there it is. That's pretty much it for this section. Fairly simple.